Hi everyone, today we're going to be talking about geometric definitions. There's several different geometric terms that we can talk about, but these are just a couple of them, and these are the only ones that I'll be testing you on. Let's just go through them right now. You also have a cheat sheet with all of these on here, but I figured we could go through them all together on this video as well. So first you have a point. A point is just what it is. It's a point. It's at a specific location in a space or a flat surface. We name points by one letter, so it could be point A, point B, point C. Then we have a line, and a line is a collection of points that make a straight line that continues forever in both directions. We always have a line as with two arrows at the end because it goes on forever and ever. Then we have a line segment, and a line segment, instead of going on forever and ever, is just a part of a line, so we end it with 2 points so that it's been cut off. Both lines and line segments we name with two letters, so like it could be line AB or line segment AB, line segment CD, anything like that. The next one we have is array. An array has a point at one end and then a line, an arrow at the other end. Basically, it starts from one point and then extends in the other direction forever. Again, we name a array with 2 letters, so like ray EF. The next thing we have is a circle. We all know what a circle is. It's basically a set of points that creates a circle or that's equidistant from the center of the circle. We name a circle with just 1 point, so we could say circle A, and that point will be right in the center. So if we have the center as point A, then this would be considered circle A. Okay, now we're going to talk about parallel lines and perpendicular lines. So parallel lines are lines that have the exact same slope. They will never ever intersect. They look exactly the same. They're just put on different places on the paper. And then perpendicular lines, instead of having the exact same slope, they have what we call negative reciprocal slopes, which means that they cut each other at a 90-degree angle. And it makes it look like an X or a T. And then let's talk about angles. So we have 3 different kinds of angles. We have right angles, acute angles, and obtuse angles. Right angles are angles that are 90 degrees. They create that those 2 perpendicular lines. Then acute angles are angles that are less than 90 degrees. And obtuse angles are angles that are more than 90 degrees. So these are all the ones that I'm expecting you to remember, to understand. And once again, you have that cheat sheet with you so you can kind of refer back to that as well. So on this self-check, and for these examples, we're going to use this picture, which has a bunch of different lines and points and whatnot. And for the self-check, I'm just going to be asking you a series of questions based on the definitions. So let's just start going through them. The first question says, name the line segment that's parallel to the line IH, or the ray IH. So as we can see, I'm going to start using different colors. So ray IH is right here. That's great. And so we want to find something that's parallel to that, which means that it has to have the same slope. Now, I know I didn't do a great job at representing drawing this picture, but there's only one line that's parallel to that, or that looks like it has the same slope, and it actually is this one up here, which is CE. And remember, we write line segments with 2 letters, so I can write that this is CE. I could also say EC. In that case, it doesn't really matter. The only time that it matters what order it goes in is when it's array. When it's array, you need to write the point first and then the arrow. So like IH is array, you say ray IH versus ray HI. Okay, the next example is asking us to name an acute angle. So an acute angle, again, is an angle that's just less than 90 degrees. And there's several acute angles in here. Let's look at them. So one acute angle is from I to D to F. Another acute angle could be from A to I to C. We could say one's from F to I to H. All of these are considered less than 90 degrees. We could say C to I to H. So all of those, once again, are less than 90 degrees. So we could write any of those. I'm just going to pick one of them. Let's say IDF. We didn't talk about this, but when we name angles, we always put this sign right here for angle. And then you name them with 3 letters. So like the one you start with, and then the middle, and then the last, so you know which way you're going. So from I to D to F creates an acute angle. And once again, there were several of those acute angles, so it didn't necessarily need to be IDF. We could have said any of them. Okay, the third example is asking what we name AF. Like, what is the name for A to F? Now, A to F is a line. We know that, but because point A is a point and point F is a point, instead of them being arrows, this would be considered a line segment. So that's my name for it, line segment, because once again, there's no arrows attached to it. It's not a ray and it's not a line because lines have both of those arrows going through them. But because there's 2 points, it's called a line segment. All right, and then the last example is asking us what ECD is defined by. So let's look at ECD, which is, I'm going to use red now, is from here to here to here. And so remember, when we have 3 letters like that, it's asking us about an angle. So we automatically know it's going to be one of those angles, the right angle, acute angle, or obtuse angle. And if we look at that angle that I just drew in the red, is that more than 90 or less than 90 or 90 exactly? In this case, it's more than 90 degrees, which means that it's called an obtuse angle. So my answer for this example 4 would be obtuse angle. All right, and there we have it. This is how we deal with these geometric definitions.